We're excited to bring you the HSM and Fusion best practices today. Bruno's one of our normal presenters, and today we're also going to have Phil Brown from Autodesk. He's going to give us a preview of nesting in Fusion, which is a new development that came out earlier this year. So it should be a pretty exciting agenda today. If you haven't been following Fusion, it has been expanding quite a bit recently, and they have added some different extensions. And so I just wanted to go over these at a little bit of a higher level. In fact, maybe we should go back to this other slide first. That's okay. Let's just stay on this slide. Anyway, there's the additive build extension that has actually been out for a while. I think it came out, was it early last year? Phil, you might know the exact date when it came out. I think it was early last year.
Yeah, it's been out for a little bit at this point.
Yeah, and generative design has been very popular. If you guys know, there's been big stories about Airbus and General Motors using this to redesign their parts and do really interesting things about lightweighting and changing really the way parts are made. That's more of a design extension for someone early in the design process. One offering on here that's on the far right here, the manage extension, is really exciting. They haven't had true data management in Fusion. Now they have had the ability that you can see all the parts since you're in the cloud. Everyone's kind of working together. So the collaborative aspect has been really strong, but now they've added the manage extension so that you can manage things like bill of materials, your revisions, and your changes. And it's just kind of a nice new little package. It came out, I think, earlier this month. And it comes in at the $495 price. So it's another way just to kind of double the capabilities that you have. So looking further into the extensions, the machining extension, this comes with a lot of the advanced CAM products. So if you have feature CAM or Power Mill, Power Shape, some of the Power Inspect stuff, some of those versions already have the extension. It comes with Fusion and it comes in that bundle. And if you want to buy it separately, it's an additional fee to get the separate extension of the capabilities that they have in there. And then we come to the nesting and fabrication extension. And this is what we're going to go through, because I think a lot of you that are out there and you're working with a CAM product, there is some nesting in some of the other products that we have. But we thought that the way that Autodesk has gone about nesting and fabrication was a nice addition to this package. And so I'm going to hand it over at this point to Phil Brown. And Phil is the master of taking big blocks of material and turning them into smaller blocks of material that are more expensive. Is that good, Phil?
That's good. I like it. Definitely works. Can you hear me?
Yes, we can hear you.
Awesome. So yeah, my name is Phil Brown. I'm a machinist by trade. I've been at this 10 years. A little bit about me. I also own a plasma and router table in my garage, nonetheless. So I actually use the nesting and fabrication tab or page constantly when it comes to Fusion 360. At this time, everybody should be able to see my screen. You want to go ahead and confirm that for me?
We got you.
Awesome. So I always like to start simple and get advanced very quick, because it always seems easier to know how to turn on your car before you ever drive your car. So the first thing I always do is, if I've already got my design completed, or if I'm just rerunning a couple of parts, I just jump straight to the manufacturer tab and I go right on over to fabrication, and then I could say component source. As you can see, this is currently a blank brand new file I opened up. It allows me to go out and pick whatever it is that I actually want to nest. So in this case, I have these 4 parts. They're all separate parts in their own, but I can pull in a bulk of parts in one shot. As you can see too, is I have things like quantity based on this, my material type, and my material thickness utilized for my nest. This is one big thing that sets Fusion's nesting apart from another software, is we no longer care about a flat DXF file. We actually give that file thickness, which allows us to create our nest based on that. That being said, is if we walk through these menus a little bit here real quick, you can see I have my 4 shapes that I pulled in. I have my packing sizes. As you can see, I have 2 different packings here. One is steel 70 thou, one is steel 90 thou, and a 4x8 sheet of each. So this is actually already looking at my parts to be able to say, you're gonna at least need this material and this thickness. What controls how many of those is gonna be my quantities. So let's go ahead and plug some numbers in here. Let's say I need to do 41 of this one. I need to do, let's say 107 of this guy. Maybe we just need a simple 100 here and 5 on the last one. So this is where I can control my quantities of each part on that nest. A few other cool settings that I have, if you're somebody that currently works in wood and run a router, we all know a sheet of plywood costs about the same as a brand new F-150. So that being said, is I may actually want to increase my calculation time to squeeze every inch I can out of a piece of material. Or if I'm just cutting some simple plastic, it's dirt cheap or a scrap, I can actually turn this number down to relieve some processing power on my computer. Lastly, when I output my stuff, Fusion it's kind of its own when it comes to this manufacturer model idea. That means it's going to auto place my parts, and it's also going to give me a stock body to work off of for cutting those parts. So what you're going to see me do is I'm going to hit OK. You're going to see a little bit of a calculation, and just like that, it actually placed out all of my parts and my pieces. So at this time, I know for my first nest, or as I like to say, this is my first sheet thickness, I need one sheet, and that's the shapes that I need to cut on that sheet. On my second thickness, I actually need 2 sheets here, same thickness, but you can see I have one placement and a second placement automatically. The real nice thing about this at the end of the day is I also get this little blue line in here that allows me to go in and cut off a drop with a nice clean edge. So Fusion's actually already thinking ahead of me for that. A few other things that I really love before I get into my tool pathing is to go in and actually look at a report based on what I'm creating. So I've already plugged in some numbers for material cost, and from a very high level out the get-go, it says I need 2 different types of material thickness, and I need 3 sheets total. It's going to cost me $330 to buy it. However, I'm only going to consume roughly $220 of that material because of those couple of drop pieces. When this is used for quoting, which is what I tend to do at first, is quote this for a customer, they're going to have to buy full sheets. There's no doubt in my mind. Truthfully speaking, I'm actually going to recoup some of my material cost. Another nice thing about this is that you can actually go through and look at each one of your sheets to where it's going to tell me the thickness, the material type, when it was calculated, and what is that actually going to cost for my customer at the end of the day. And you can print these, you can send these to your customer. It's really up to you what you do with this report at the end of the day, giving you that power to really get more accurate quoting before you ever even turned on a machine. And as a lot of you can see, I did a lot of this within 5 to 10 minutes. That could be all the difference on making or losing money on a job because somebody got the decimal in the wrong spot. So from here, let's go ahead and start to generate a couple paths. First, I'm going to activate my sheet that I want to cut. I'm going to right click on it. I'm going to go down and I'm going to say create setup from manufacturer model. What this does is it brings in that idea of where is my origin on my laser table or my plasma table to cut these parts. One thing it's also asking me for is my models. So I can quickly come in here and actually just highlight each one of these by clicking the first one and then going all the way down to the bottom and holding shift and clicking my last one. So what this is going to do is this is going to select all of my parts to be able to manufacture those or to apply my tool paths. This is also going to prevent me from getting a little bit of an error here in a moment had I not done that. So I'm just avoiding it. Just know for most people that you don't have to worry about this. If you are doing router work, one thing you need to do is you need to say milling versus cutting, or you'll also get a couple of errors just because Fusion's smart enough to know that, hey, you can't router on a laser table. So now that I created that, let's go ahead and do a cutting 2D profile. At this point, I'm going to go in and select my tool. I have a Langmuir system plasma. I simply have my plasma cutter. The kerf width on my plasma cutter is 40 thou, and I like to keep my tool up by 50. These options are fully customizable, as well as you can actually create multiple speeds and feeds based on whatever you're cutting, material thicknesses, or maybe in the fact that your controller can do this. This is common with things like a flow water jet or in a model laser, is you're going to tell the controller the speeds and feeds, to which then this will be ignored. What it's asking me for is to pick what is it that I want to cut. I'm actually going to zoom in here real quick, and you're going to see with my mouse, I'm going to highlight that first square and pick it. You could pick whatever square you choose at the end of the day, but I'm going to go ahead and just check mark and say pick everything on that plane. Just like that, I actually went ahead and selected all of my parts for cutting, using that plasma cutter start to finish to cut all my shapes. And then lastly, you can see I actually get an error here, which is kind of nice. So it says one or more was discarded due to linking. I can tell you from my experience what's going on there is if you think about my lead in and lead outs, they're probably too long to bridge that gap between my parts. We'll come back and fix this, but let's just look at posting some G code. So at this point, I'm going to go ahead and say post process. If I'm working with a Armada laser, I can go ahead and search A's, scroll down to my Armada laser. In this case, it won't let me do it because I'm using a plasma cutter. So let's just jump down to maybe like a Mach 3 plasma post or something of that nature. So Mach 3 plasma post. I have some properties here I can toggle on and toggle off based on certain scenarios. Sometimes you have a Z-axis, sometimes you don't. Sometimes you have a torch height controller. It's just based on your machine and what you're doing. This is where I would take something from a thumb drive, transfer it over to my Mach 3 software or my Armada controller, whatever laser, plasma, or water jet you're using, and I can spit this G code out and run my machine. From here, let's go back and make a couple of corrections. So judging by my quantities, my option is one, either change my spacing or change my lead in and lead outs. Let's start with the lead in and lead outs since that's the simplest thing here. Let's go to my linking tab. Looks like my lead in distance is almost 200 thou. What if we bump that down to roughly 0.1 and go ahead and hit OK? This should remedy my problem. If not, I could shorten that length up a little bit if need be. As you can see, it did remedy my problem. Or I have the ability to always go up and just change some things like the spacing on my material. So for example, this is my packing size and my cost. So that's where we're getting that for our situation, as well as if I wanted to add some trim to the outside of the sheet because it's not square, but I can actually go in and say anytime on an 80 thou thick piece of steel, I want to space my parts out a minimum of 1/4 inch to each one. And just like that, I can make these changes. And what that change is going to do is tell me, first off, I need to regenerate my part. So let's go ahead and do that. I'm a fan of hotkeys, so I'm going to push Control G and hit yes. And what that's going to do is actually redo my tool path. And that's because I selected the wrong thing. So let's go back to the top and generate the nest. So you're not going to see a 50 thou shift on anything here, but it actually did change the number of sheets that I need to make this part, which is kind of crazy at the end of the day when you think about that from a little bit of a spacing. So at this point, this is a good workflow. As I like to say, this is my get everything out by Friday workflow, where I'm going to go out and just grab all the parts that I need by Friday. I'm going to nest those out on those sheets, and then I'm just going to get my plasma cutter running as fast as possible. Another workflow that I find a lot of people utilizing is the idea of what if I have an assembly from my customer? The neat thing is with this assembly, as you can see, my customer can send me over anything and everything here, and I have that ability to take this and in Fusion, I can convert it to sheet metal, or I can nest out whatever it is they have. So instead of me getting a source component, I actually have my source in the file. So this is what I like to think of as my quoting strategy for nesting out a part. So we're going to go ahead and create another nesting study. Maybe my customer only wants 5 of these. Same kind of concept. We have our packing sizes that, as you know now, you could edit and change, as well as my output options. So there's not a lot more that I'm going to do at the end of the day on this file. And as you're going to see, it's going to go ahead and calculate all those sheets again, getting me to those results. So as you can see, based on a sheet size that I'm pulling from, that's all I'm going to fit there. So I technically need 3 different sheets cut out with these profiles. In this case, down here at the bottom, you can see I have a quantity of 4. Well, my sheet is so small, I actually need 4 of those sheets identical. So again, we're going to squeeze as much as we can out of what it is that we're doing. And one part that did actually sneak through that I would never nest, as you could see, is these pins here for manufacturing. So this is where I have some control over my nest from when it was a design. So let's go ahead and jump back to my design side of things. And as you can see, this is my complete assembly for this plow. I can actually go into my tools tab and do a nest preparation. And what you're going to see here is, yes, I've done a lot of different things in here where I've ignored certain things. and made sure that they didn't automatically select. But for example, if I'm looking for a specific part, or if I know there's a quantity based on that part, just so happens it's that nice little pin right there causing my problems, I can say ignore, because this is a store-bought part. I don't need to actually go through and nest it out. However, these custom washers is something I really do want to nest out at the end of the day. So just like that, I can ignore a component and then jump back into my manufacturing tab and actually regenerate or just delete that nest that I've already had. And if you guys look here, we actually eliminated it completely from the nest automatically. So Fusion is even smart enough to see things like that. I know at this point we have covered a lot when it comes to welding and fabricating. The same concept at the end of the day will still also apply to the nesting of wood components. So if you're a cabinet maker, or you're somebody out there that's going to be doing intricate things, this part here just so happens to be a printer stand for road shows or farmers markets, depending on what you're doing. It's all been designed and sketched up, ready to go. I just need to kind of do the same concept. Let's go ahead and create a nest study based on wood. Same concept applies. I can nest it in the assembly, or I can nest it out with several other things that I'm working on. We're just going to say 10 of these. My packing, as you can see, is even recognizing these boards are pine and the thickness of that pine, to which when I nest this, it's again, same concept, start to finish, makes life very simple to get straight into doing things with a router. The only difference I really find myself doing between a router or actually cutting with a laser table is the separation between my parts at the end of the day. That's really all that I find myself making a difference when it comes to nesting in Fusion 360. But the same is still in there. If I want to compare these, if I want to look at material costs for my customers, if I want to look at my nesting sizes, if I want to quote this, I could quote this out probably in 10 to 15 minutes, apply some generic toolpaths, and give my customer a much more accurate idea of what it's going to take. Outside of that, nesting is relatively a very easy thing to learn. I personally have learned it by clicking a couple of buttons. For a lot of you out there that are curious about nesting, you do have the ability to actually turn on the nesting extension for a 7-day free trial. There will be an option here based on what's going on. It's nothing more than a drop down and clicking, hey, I want to try the 7-day trial. And with that, you also have the option of turning it on for a 30-day. Or what really works best is if this is something you really see yourself using all year long, I just use it on Saturday and Sundays. It paid for itself in about 2 weekends after one of my neighbors saw my fireplace. That being said, you could turn it on for the year for a much better prorated price. I think at this point, if there's any questions, people are more than willing to ask them at this. But that is kind of wrapping up nesting as a whole for a start to finish procedure when it takes either assemblies or individual parts and nesting them out for manufacturing.
A question, there were a couple questions that did come in. One is, do you have to do a lot of setup for your operation in Fusion just to kind of get it all, set up with your pricing and your sheets, and what kind of setup is required?
So the great thing is a lot of times it's self-recognized as you go through Fusion. So the first time you ever nest something, a lot of these packings are getting pulled automatically or generated on the fly. It's just a matter of you going back and either editing them to what size you want, or actually saving them out to be pulled from later. So you don't necessarily need to go in there today and set up every single sheet that you've ever touched, because as you're nesting, it's going to start to generate those sheets and store them in your library.
Okay, that's great.
So it is very much out of the box friendly. So I will tell you, the first time I ever ran it, I went in and clicked about 10 buttons and I had a nest, and I'd never even seen an article or watched a video on it. And I figured it out very quickly on my side.
Awesome. One question that did come in was just around installing this. So is this a separate install? Obviously it's in the cloud, and I know the Fusion install is very quick, but is this another installation, or is it just you're adding it into the cloud?
Nope. So this is actually already installed with Fusion 360. All you have to do is, like I said, is you can either purchase through Next Gen CAM, the nesting and fabrication package, or activate that 7-day trial right here through the extension manager. Nothing actually even downloads or installs. It just automatically turns on in the background. So you technically have it there, it's just not activated. And keep in mind that although Fusion is a cloud-based software, it's more of a hybrid. This is still installed on my computer. If my internet for some reason was to go out today, I can still do nesting just fine. I can still work with what I'm working on. The only difference is a lot of my files are stored in the cloud. That's it. So when it comes to machining or manufacturing, I always laugh about this because it is still a desktop install. Nothing that you guys have seen me do other than open my file technically comes from the cloud.
Can you do nesting based in a sketches in a sketch, or do you need to add a thickness to the part?
So at the end of the day, you can. I really don't recommend it because if we started with a simple sketch, regardless of what it is that the customer is working with, it's very easy for me in sheet metal to just say flange, click that part, and then I have a much more advanced feature here where I can have sheet metal rules. And in your rules, you could have the thickness, the K factor, and things like bend condition. Why that's important to give it thickness is so that it puts the same thickness, same materials together. Also, if you're somebody like myself that enjoys making some crazier things here, you could see how I could use that same flange tool and create my sheet metal part, then do a flat pattern. And although you could have that DXF with that flat pattern, you're going to miss out on things like your bend radius, start point, end point, and center points for your manufacturing at the end of the day. So it's one of those things. Can you do it? Yes. I do not recommend it because you're almost forcing Fusion to do something it doesn't like, especially when I can add thickness to something in a few seconds.
And what about if you import a file of a sheet metal that came from another software? Is nesting able to flat pattern that imported file?
Yeah, so for example, if you brought something for SolidWorks and it was sheet metal, given that it is the true thickness everywhere, you can actually convert that to sheet metal and then create a flat pattern of it. So we do have that ability to translate a SolidWorks sheet metal part, lay it flat, and then take it over and cut it out on your laser or plasma.
Okay, that's good to know.
I do know we have quite a few people using Fusion with the laser and just using on their water jet and that sort of thing, right? That's been there. That's in the base Fusion 360, if I recall.
Yeah, so realistically speaking, I could always take this part that we just drew in real time, and I could actually take it and go cut out one of them. There's no doubt that you can't do that, as you're going to be able to see here. Give me one sec here. I kind of clicked the wrong line. I can go out and cut this part relatively easy and run one of them. The true value of the nesting situation is when I needed to make 100 of these, or if I need to make 10 of these, or 50 of these. I always laugh because on my plasma table, if I'm going to go through and nest something like this, I have some dead space areas that what I tend to do is squeeze in business cards. It's a simple design. It's the size of a credit card, and it has a cutout to open bottles, and it has my name on it. But anytime that I could squeeze some of those in there for free, it's something I throw in a box of parts or throw on a pallet of parts,